Hello, this is Bill with What Kind of Math Is This? And today's video is going to be on how to determine if a table is a function or not. And let's go ahead and get started. For you, I have 6 examples. This is actually going to be not too long of a video because it's going to be pretty simple. Now let's start with understanding what a function is. A function says that for every x, we have a y. One y, not multiple answers. Therefore, we cannot have, and here's the key, we cannot have inputs or x's that are on the same or that have the same number. And I want to go and start with this first one. All right, if you look at number 1, let's look at x. And of course, this is just a normal table, input output table. We've been working with these since 3rd grade. If you notice here, 16, so I'm good. 64, okay. 81, okay. Now, I have two 81s, and what that means to me is that I am going to have an x that has two x's that are the same, and automatically that tells me that this table does not demonstrate a function. I can stop there. I don't have to worry about going on either anymore. All right, so go to number 2. All right, negative 54, negative 36, negative 12, 48, 60. This is actually going to be a function. Go for this one. And that is because every x is unique and has one output. All right, every x is unique and has one output. Let's look at the third one. If you look here, 60, good. Negative 18, good. Negative 12, good. 30, 54. This is going to be a function table as well, again, because you have unique inputs. Only one number in each category. Now, let's go down to number 4. I can go ahead and tell you that this is not going to be a function, and the reason is, if you look right here, we have 49. That means we have two of the same inputs. I want you to picture this with me. If you had a coordinate plane and you're on the x-axis, remember that's the horizontal one, you're on the x-axis, and of course it had to be a really big one because we're over on positive 49. So we cannot have two plots or two marks on the x 49 line. That disqualifies it from being a function. So there you go. Look at number 5. Okay, negative 7, negative 6, 3. All right, you see this right here? This is what tells me that it cannot be a function. So this is not a function. And now we look at number 6, negative 8, negative 3, 3, 6, 9. Now, this is going to be a function because there is a difference between a negative 3 and a 3. So there is a difference between a 3 and negative 3, and of course the difference, of course, is 6. Now, this one has one that I want to end this video with because I want you to see. If you look here, you're going to see there are two 9s. There's a 9 there, and there's a 9 there. Now, you may be thinking to yourself, wait a minute, Mr. Dobbs, wait a minute, Bill, you made a mistake. There cannot be two 9s. That's not a function. It cannot have two of the same number in the x input. However, it can have two of the same in the y output. That is because, again, imagine with me on a coordinate plane, we will, and actually let's do a quick one here. Of course, this would be 1, 2, 3. This would be negative 1. This would be negative 2. This would be negative 3. This would be 1, 2, 3. And of course, 1, negative 1, negative 2, negative 3. All right, real basic coordinate plane. All right, if we have negative 3, 9, that would be up here somewhere. And the other 3, 9 would be over here. Now, do you see how we have a unique output for each input? And that's why it's a function. So this was a quick little video to tell you or to how to spot whether or not a table, an input-output table, is a function table by looking for a repeat of the same number in the x category. Not the y, the x. This is Bill with What Kind of Math Is This? I hope this quick little video helped you, and I hope that you have a great day.